Okay, we're on page 23. Okay, so this is a review of the Algebra 2 stuff. We're going to do linear programming, which means we're going to use, we're going to use system of inequality to solve some word problems. But first, we need to recall some vocab. First, objective function. Objective function means the function we want to maximize or minimize. So whenever you see the words maximize or minimize, that's a hint for objective function. Objective function is the objective of the problem or the goal of the problem, whatever you want to maximize or minimize. The second one is constraints. Constraints are a list of inequalities that contains the feasible region. So when you graph all the constraints together, they're all going to shade into a region, and that region is what we call the feasible region. So that's the next vocab. The feasible region is the region that contains points that meet requirement or meet constraint. So everything in the feasible region works, and they make the constraints work. But only one or a few may meet the objective function, and they are the vertex points. Vertex points are the corners of the feasible region. Okay, so we're going to do one, not a word problem, and then we will do probably 2 word problems today. Hopefully we can do 3. Okay, so let's look at this problem. Find the maximum and minimum values of the objective function. And the objective function they tell you is 5x plus 8y, subject to the constraint given by the system of inequality. So these ones. Okay, so you need to graph those, and they are going to shade into a particular region. From that region, you need to find the vertices, which are the corner points. Okay, so go ahead and graph them. And once you have the list of vertices, let me check them. Okay, so this should be your feasible region. That means we have 4 vertices. 1, 2, 3, 4. We need to list them. Okay, so this one on the bottom left, that is what? Not the hard one. 0, 0. Good. What about this one? This one on the left top, this y-intercept for one of the lines. 0. Okay, let's give 14 over 3. Yeah, so you want to have the exact numbers just in case we need it. Okay, so first one is 0, 0, and then 0, 14 over 3. Okay, let's go to the bottom right. This one is what? 7, 0? No. 5, 0. So it's an x-intercept for one of the lines. The hardest one is this one here. It is 4, 2 in this case, but what if it's not actually on the grid? Yes. So if it's not actually a point on the grid, then you need to solve on your own. So remember that your boundary lines for these inequalities were actually from these equations. So this one is 2 x plus y equals 10. This one is 2x plus 3y equals 14. And that point where they intersect means when the equations are equal to each other. So then we can just use system of equations to solve. Okay, so that means when is 2x plus y equal to 10 equal to 2x plus 3y equal to 14. You can solve it any way you want. The way I see this problem is that I see 2x repeating, so what I can do is just say 2x is equal to 10 minus y. And I'm going to plug this into this 2x. So 10 minus y plus 3y equals 14. So that's 10 plus 2y equals 14. 2y is 4, so y is 2. Now I just plug it back in to solve for x. So from the same equation here, 2x is equal to 10 minus 2. 2x is 8, so x is 4. So in this case, you didn't have to do that because they do match on a point. But if they don't, you will have to do this in order to figure out what that point is. You cannot guess. Okay, so the last one is for 2. So out of these 4 points, we are trying to figure out which one is going to maximize and which one is going to minimize my objective function. The objective function is actually given to me, 5x plus 8y. So what I'm going to do is plug all those points into 5x plus 8y. First one is very easy, 0. The second one, not as easy. So 5 times 0 is 0. 8 times 14 over 3. Someone find it and let me know. One and 12 over 3? That sounds too small. 112. Oh, sorry. You meant 100. How about a like rounded number? Because we're trying to compare, so it'd be nice. 37.3. Okay. All right. 50. That's gonna be 25. 42. 20 plus 16. So 36. Okay. Let's make sure we are answering the question. Find the maximum and minimum what? Okay, so it says maximum, minimum values. What does values mean? Are they asking for the point or are they asking for the actual value? Actual value. So make sure you read the question. They want the actual value. So the smallest number is 0. The biggest number is 37.3. Or the not rounded version. If they say which vertex is going to minimize, then you have to give them 0, 0. So make sure you read the question. They just want the values, not the vertex. Good? Okay, let's go into word problems. Johnson's Produce is purchasing fertilizer with 2 nutrients, N, nitrogen, and P, phosphorus. They need at least 180 units of N and 90 units of P. Their supplier has 2 brands of fertilizer for them to buy. Brand A costs $10 a bag and has 4 units of N and 1 unit of P. Brand B costs $5 a bag and has 1 unit of each nutrient. Johnson's Produce can pay at most $800 for the fertilizer. How many bags of each brand should be purchased to minimize cost? Too much information. Information overload. When that happens, you know, no matter what you do, you always go back to the question. That's the most important part, right? This is what they want you to answer. So I want you to read this question again with your partner. You guys are going to decide which ones are the variables. Is it N and P or brand A and brand B? Okay, look at the question and then talk to your partner. Which one is variable? All right, let's decide on the variables first. How many people think N and P are the variables? Raise your hand. How many people think brand A and brand B are the variables? Good. Why is that? Your partner says so. It's not that difficult.
How many bags of each brand?
Yes. How many bags of each brand? So remember, look at just the question. The question tells you what you should find. How many bags of each brand? So the brand must be the variable because that's what you need to solve. Okay, so brand A and B are the variables. So let's give it X and Y so we don't confuse ourselves. N and P are going to be extra information that we need, but they are not the variables. If you don't look at your question that way, it's very likely you make N and P the variables and then you realize you cannot solve or it takes you way too long to solve. Okay, here's what you do. This kind of question, you want to have a table. X and Y goes on the left. That's your brand A and brand B. And then N and P are going to be the stuff that you get from each brand. Okay, now we go back to the question. We need some amount of nitrogen and phosphorus. If I buy one bag of brand A, how much nitrogen will I get? If I buy one bag of brand A, how much nitrogen is in there? 4 unit, whatever 4 unit means. So put 4 there. And if I buy one bag of brand A, how much phosphorus is in there? 1. Okay. If I buy one bag of brand B, how much nitrogen is there? 1. And then how much phosphorus? 1. Okay. So this means if I buy X bags of brand A, I get 4 times of that amount of nitrogen. If I buy Y bags of brand B, I get 1 times Y amount of nitrogen. So no matter how many bags of each one I buy, the total of amount of nitrogen is always going to be 4 times that bag plus 1 times the brand B bag. Does that make sense? Just go straight down. 4 comes from this bag, 1 comes from this bag. This is how much I have total. Okay, and the same thing with phosphorus. It's going to be X plus Y. Now let's look at the question again. How much nitrogen do I have to have? Nitrogen. 180. So how do I write that as a constraint?
X has to be...
Not X. Remember, X means brand A. I want, N? Well, what's N total? Total amount of N. Yes, 4X plus Y is my total amount of N. It has to be what? At least 180? Sorry, yes. So 4X plus Y has to be at least 180. So this is a tricky problem because it seems like you have 4 variables and they're kind of like linked to each other. So you got to set up a table so you can clear your thoughts a little bit better. How about phosphorus? 90. So X plus Y has to be greater than or equal to 90. What other constraint is there?
X and Y.
X and Y? Something has to do with cost, right? We don't have that much. We don't have indefinite amount of money.
It has to be at most 800.
Okay, so we only have $800.
And brand A costs 10.
Brand A costs 10. Brand B costs 5. So how do I write that as a constraint? 10x plus 5y at most 800, less than or equal to 800. Okay, so those are my 3 constraints besides my implicit. Implicit means, we cannot buy negative amount of each one, so it's going to be, both of them are going to be greater than or equal to 0. This is implicit. Like even if they don't tell you, you wouldn't give them a negative answer anyways. Objective function. Remember I said objective function has to do your maximum or minimum. So what do they want to maximize or minimize? So look at the question again, just that last line. The cost. We want to minimize the cost. So can you write a function for the cost? how much would it cost total as an equation? Yes, 10x plus 5y. It just happens to be the same as the constraint, but it is the objective function. We just want that number to be as low as possible. Okay, so for the sake of time, I'm going to have you do this in decimals, so it's faster. But on the test, you don't get decimals, so you do have to graph by hand, but I'll have the graph paper laid out for you. So if you haven't gotten the answer to this one yet, there are 3 vertices. They are 30, 60, 10, 140, and 70, 20. The one that's going to minimize cost is 30, 60. So that's 30 brand A, 60 brand B. Okay, so if you have not started, go on to the next one. Make sure you work with your partner so you can kind of help each other figure out what the variables are. Remember, it has to do with the question itself, not the details.